So we're going to talk about sinusoids. All right? And at this point in the class, I don't know how to make this not awkward. Why sinusoids? Who talks about that? Who invited? It's like, it's like when someone shows up at the party and they're not invited, right? Here's why are there why am I it's not quite motivated yet, right? But it will be motivated. The equation for a sinusoid looks something like this. You have voltage, or it could be any function as a function of time, is equal to A sine of let's use B times T. And if you were to plot that over time, it would look like this. Right. So here we have time. Okay. This is just a function, right? The sinusoid function that you're familiar with. It goes up and it goes down. It gets as big as plus A, and it gets as small as minus A, right? And it wiggles up and down and up and down. Okay. The time that it takes to complete a wiggle is called the period. And I should be clear here, this A is the amplitude. Now the amplitude is in units of volts, right? So like if this was 10, it would go plus 10, minus 10, plus 10, right? So the amplitude is in units of volts. The period is in units of time or seconds. All right? Yes? No? Are you asking me about frequency? Here and then here, but you're right. I could have also drawn it from, maybe I didn't draw it clearly. I was trying to align it from here to here. I didn't draw it clearly. I could have also, and to be clear, it's very regular, right? So I could have also, maybe it would have been clearer if I made the period from here until here, right? And that would have been the same thing. All right. Now, the period, how long this will take, is 1 over 2 pi b, right? Higher the b, the less it is. Or is it 2 pi over b? 1 over 2 pi over b or 1 over 2 pi b? 2 pi over b. It's 2 pi over b. What does that mean? It means that if b was 1, so if it didn't exist, right, then every 2 pi, 2 pi seconds, it would repeat. Every 2 pi seconds, right? And that is just how the sinusoidal function works, that it cycles every 2 pi. All right, so now we have a period. And so you can see that if I give you A and I give you B, you can create a sinusoid. If I gave, if I gave a slightly different A and a slightly different B, I'll do it here, you might find that you have another sinusoid, right? With a different equation or a different equation, right? But these are the only parameters, we'll talk about, we could deal with phase later, right? But this is the only parameters, so this is a sinusoidal function, all right? I can get a device a physical, okay. Man, where's my good markers? I can get a device called a function generator. Function generator is an instrument. It doesn't have to be an angle like this, and it provides a voltage. Let's call it Vs, right? And this function generator can do a couple things for me. One, it has a switch.
Also a wave generator on a single box, or is it different?
Or your wave, yes, or a wave generator, yes. Yes, wave, we could call it a wave generator. Like a wave, right? It has a switch. And the switch says, I can either generate a DC voltage or a sinusoidal voltage. Now, what do we mean by a DC voltage? A DC voltage is what we've been dealing with until now. A DC voltage, if this is time, just has a single value, such as, 1 volt, or another one could be at 2 volts, or it might be at -3 volts, right? This is a direct current. And up to now, whenever we talked about applying a voltage, I meant a direct current voltage, like a 9-volt battery. And you can use that, you can get it from a 9-volt battery, or you can get it out of the supply. Or I can switch it to a sinusoidal mode. And if I switch it to a sinusoidal mode, it will generate a voltage that isn't fixed, but is alternating over time. Now, if I switch, now in either case, it is asking me what is the amplitude. But in sinusoidal mode, it's going to ask me something else, right? Because in sinusoidal mode, it needs to know not just the amplitude, but it needs to know the period as well, right? Or the B term, right? So I need that as well. So it's going to ask me for the amplitude, and for the sinusoid, it will also ask me for the period. If I give the function generator an amplitude and a period, it can provide for me the sinusoid that I want. So far, so good. Instead of period, we will often use frequency, which is 1 over the period. So if the period was 1 second, that would correspond to 1 over 1 is 1, and then we would use the term hertz. Hertz is 1 over seconds. If the period was 0.1 second, right, then the frequency would be 10 hertz. And if the frequency was 10 seconds, you get the idea, we would get 0.1 hertz. So when describing how much these things wiggle, we do need to give an amplitude and a period, but more conventionally we will refer to the frequency. The frequency, you can think of it as how much times it wiggles up, it completes a cycle per second. So a 1 hertz signal goes up and down and comes back, and that takes a second, so it does it once per second. A 10 hertz signal goes up and down and up and down and up and down, and it does that 10 times in a second. It's quicker. Well, a 0.1 hertz signal, right, it takes a full 10 seconds to complete its cycle, right? So this was your review, right, of introduction, as I'm sure you are familiar with this function and what it represents. And yes, I called this a function generator. You could also call it a wave generator. Here's our wave. The wave goes up and down, right? And the use of either DC or sinusoidal functions is very universal, right? Is very universal in circuits.